It's Advent of Code 2020, day 11. The problem is called seating system. We've arrived at the final leg of our journey, and there's a ferry that's going to the tropical island. That's exciting, and we're trying to figure out the best place to sit. So we've got sort of a seating chart that we've put together based on just observing the grid of seats on this ferry. And we sort of keep an eye as people sit down and get up. The L's represent seats that are empty. The dots represent floor. So there's a bit of flooring around some of the seats. And then if a seat ever becomes occupied, it's represented with this hash symbol. And essentially what we've got here is sort of a modified version of the Conway's game of life problem. So there's some different rules that are applied for sort of each tick of the board, of the grid, that determine whether a seat stays empty, whether it becomes occupied, whether it goes from occupied to empty, or whatnot. The floor pieces always stay the same. They'll just always be floor. A seat is empty. If a seat is empty and there are no occupied seats adjacent to it, then the seat becomes occupied. And so adjacent seats are seats that are sort of above, to the left and the right, below, and then the diagonals. So kind of the 8 spots around a given seat. So if those are empty and the seat's empty, then it becomes occupied. If the seat is already occupied and 4 more seats that are adjacent to it are also occupied, the seat becomes empty. So if we had this marked as occupied and then 4 more of them around it became occupied, then for the next tick, this would then become empty again. And if those 2 conditions aren't met, then the seat just stays unchanged. Whether it was occupied or empty, it'll just stay how it was. Like I said, the floor never changes. And so I think after we have our layout, the very first tick is just mark all the seats filled. And then from there, we keep updating it one by one by one until eventually we hit a stable state where the seats no longer become empty or occupied. So we want to sort of take the seating chart, process it until it hits a stabilizing state, and then count the number of occupied seats. So there's a lot to do here. I'd like to work on a solution, a generalized solution that works for this initial small input, and then we can work with the bigger input after that. So I'm going to copy that and jump over here to the day 11 directory, and we'll say sample.txt, and I'll just paste that in, and we'll save that. And now I want to open up part1.ruby, and we'll start by reading in this file. So we can do that with file gets file.open, file.read. Every single day I mix up which one of these it is. Let's see. Day 10, part 2, it's file.read. Okay. File.read, sample.txt, and then we can split this file based on the new lines. This is just a little rigmarole that we do every day when we're reading in a sample file to parse out the input. So we split it on new lines, and then we split it on, actually we need to map over each of these lines. I'll say line.split on an empty space. So we'll just split up. If we look at sample, imagine we'll split each of these up into a row, and then when we split on an empty space, then this will be its own cell, this will be its own cell, this will be, so on and so forth. So here we get like a 2D array of seating, something like that, and double array of seating. How about that? And I think it would be nice to work with a little more structure on this problem. So let's say class grid, and we can initialize this with a double array of seating. And we can assign that to some instance variables. So say seating chart, something like that. Gets that double array of seating. And then the one other thing I want to do to get us started is then have like something where we can print it out. So print, and then we say seating chart dot each do row, so seating chart dot each do cell, and then if we go back to day 1 part 1, print and flush, I think we want something like this. That in here, be like a little private method for our class, and so we will we'll print and flush just the contents of the cell, and then after each row we will, I guess, puts a new line, maybe. So let's see if that works for us. So if we say grid.new double array of seating, pass that in as the argument, and then say grid.print. Not quite. Print and flush, wrong number of arguments. Oh, whoops. This is row.each. Given 1, expected 0. Print. Print on line 11. Oh, I've 2s, no. Right, print is already a Ruby thing, so I need to grid.display. Just need some sort of name for this. There we go. So that seems fine. That I don't like. I think maybe I got this wrong. There, that's better. So now we have a way of consuming a grid, creating an object from it, and printing it out to see how we're doing. Lovely. So what do we want to do next now that we have this grid set up? I guess we have these rules that we need to account for. And these rules, well, I'll copy these over, but I think one other thing I'd like to do is have a way of counting whether seats are, how many seats are occupied. So let's say def occupied count, or count occupied, like that. And we can say seating chart.each do, and it's going to have a similar setup to the display method. I guess we don't need to, it doesn't need to be an each though, it could be a sum, and then this could be a sum as well. And then cell equals this. Then we return 1, otherwise 0. Kind of curious if that'll work. We say grid dot puts grid dot count occupied, and I expect that to be 0. Okay. We'll have to keep an eye on that, because once these start coming in, we're going to want to make sure it counts them correctly, but I feel pretty good about the way we've implemented that. Okay, so now our rules. We're going to want to have something that applies these rules to the grid. So maybe we can say tick, and each time we tick the grid, we can just update everything based on the rules. So let's paste these rules in. So tick will, grid.tick will update. Yeah, we might do a similar thing of like iterating over all of the positions in the seating chart. Like that, and then for each one we want to check the occupied neighbor count, and then do some things based on these rules. So this is jumping out as me as something we need to do first, is given a cell, count the number of occupied neighbors. And so I think we can, count occupied neighbors. And we're going to need a position. So we need like an X and a Y so that we know where we're looking. So X and Y would represent like that particular seat. And then we'd want to look at the 8 seats, or 8 positions around it, and see whether they are occupied or not. So yeah, let's think about that. So So these dots represent the different positions. So we kind of have like x minus 1, y minus 1 for this first position here. Then we have so the x is going to represent the row. So we're moving along this axis with the x, we're moving along this axis with the y. So then the next position would be still, x minus 1 and then y. And the third position would be x minus 1, y plus 1. Then we need x and y minus 1. Then we need nothing, because that is our position, that x there. And then we need x and y plus 1. And then lastly, we need x plus 1, x plus 1, y minus 1. Then we need x plus 1, y, and x plus 1, y plus 1. So those are the different positions that we need to concern ourselves with. So I think in Ruby, if we have an array like this, if we get like a position like 0, we get the first thing, but what if we get a negative position? It loops around, okay. And if we have 0, 1, 2, does it loop around and go 3, 4? No, that extends off the bounds and goes to nil. Okay. So I like that we get nil going this direction. I don't like that we wrap around going the other direction. Yeah. Okay, so we're gonna have to deal with negative numbers then, and I think we'll be fine with these values extending off the right edge or the bottom of the grid. So let's see. We have seating chart. So we'll say x minus 1 and then y minus 1. Yeah, maybe what we need is actually a grid of these positions, or an array of these positions rather is what I mean. So x minus 1, y minus 1, then x minus 1, y, x minus 1, y plus 1. So I'm just kind of copying all of these things. Bear with me while I do this. Okay, so that's Yeah, that's our sort of a list of the positions we need to check. And we can call it that, positions to check. Neighbor positions. And then I'd like to go through and root out any neighbor positions that involve a negative number, because I don't want to go off like this edge or back off this direction, whether it's a negative x or y. So yeah, we'll just, I guess, neighbor positions dot filter and so each one of these will have an x and a y, and I'll say x dot positive and y dot positive. Something like that. Let's see. Okay, so that won't account for 0. So what if we say not 0 dot negative? Okay, so let's say not negative then. Rid of those parentheses, doesn't like those. Oh, and it doesn't like that we shadowed the outer variable, so we'll call this A and B, I guess. Okay. So now we have positions to check. And so we'll go through positions to check. And we'll map those into the AB. I don't like calling those AB. That kind of confuses things. Let's call it xpos and ypos. Just so that we're clear that these are positions we're checking. And we'll say seating chart. We'll return the position, that position in the seating chart. And then we will filter that down to those that to those that match the symbol. I don't know what we want to call this, but we want to find those that are matching the seat character, this occupied seat character. So state, I guess. State equals that. And then we'll do a size at the very end of all that. And And so we'll return that size, and that is going to be the count of occupied neighbors. So then, yeah, I think we have a lot of the pieces in place now. So we'll take our seating chart and we'll map over it, because we're going to sort of we're going to produce sort of a new version of the seating chart here. By mapping over it, and then we'll set seating chart equal to updated seating chart, because we don't want to update it in place, because we'll end up like messing up certain counts because of positions that we've changed earlier as we go. So we'll update the entire thing for its like current state that it's in, and then sort of reapply that to seating chart. So we'll map over rows, and then we'll map over cells. And so for each of those cells, we'll just apply our rules. So yeah, let's actually grab these and dip them down in here. So if cell is L, and we're going to need indexes with each of these so that we can have something to pass into the count occupied neighbors. So we count, map with index. I know there's each with index, but I want to enum4. I guess I've seen this one before. Okay. Each with index. And then map. And so then we get the X in the index. Okay. And now we have a way of checking. So yeah, let's do a number occupied gets count occupied neighbors of X and Y. So we can use that with our rules. So if the cell is currently an empty seat and the number occupied is 0, then we will produce an occupied seat. Else if the cell is an occupied seat and number occupied is greater than or equal to 4, then we can empty the seat. And whether it's a floor seat or something that doesn't match either of these conditions, we'll just leave it as is. So, oops, don't want to delete that. Else else we just return the cell as is. And what doesn't it like up here? Sure, we'll use that. Okay. So this will produce an updated seating chart and then assign it to the seating chart. So I like that. I think the other piece I just remembered that we have to do is we need to take the initial seating chart and mark all of the seats as occupied. So let's write something to do that. Def occupy all seats. And it's gonna look a little bit, well, I don't need to copy any of that. It's gonna be different enough. So say seating chart, map row, oops, do row, and then again row, map, cell, and then for each of those we just say if cell does not equal a dot, then we return a seat, else we get just the dot. Yeah, that's a little bit of a clunky way to write it, but I think it'll do the job. Fully occupied seating chart. Seating chart gets fully. Okay. So now if I run this thing, but I put a breakpoint in to stop myself right here, I'm kind of curious if we can play around with some of the functionality that we just wrote. So yeah, if we look at our grid methods, we can say grid.countOccupied 0, that's good. Now if we say grid.occupy all seats, that looks pretty good, and then say grid, or sorry, just we'll rerun this count occupied. Now I have 71 that are occupied. I'm not sure if that's how many are supposed to be there, but I think it is. So now I'm going to say tick. And we've got an error. 45 undefined method array access on a nil class. Okay. Well, let's take a look at that on line 45. Oh, sure, because so this is it could be nil if we go off the edge, so we could, yeah, how do we want to handle this? I guess if this is ever nil, then we want to I don't know, I guess turn it into an empty array, and then accessing a value off of that will just return nil as well. Sure. let's try this again. Ruby par1. We'll say grid.occupy all seats. So grid.tick. So now we have L's and yeah, that we have occupied and unoccupied seats. So if I tick that again, we have more. Tick that again, more. I get change. Now if I do it one more time, maybe it won't change. Yeah, I think this looks the same. And if I exit, then at this point it says 37. And is that what we have down here? Yeah, 37. Okay. So I think we have all the pieces in place, except we need to detect when the chaos is stabilized. So we're going to need a way of accounting for that. So def chaos stabilized. So maybe we can have like something like representing the previous state, like previous state hash, and it could be nil to start, or I guess it could be yeah, I'm trying to think. Maybe it's nil to start or something like that. And so then each time we tick, we should update the previous state hash to be update seating chart dot 2s dot let's see, MD5, is that a thing? Oh, digest, that's right. Okay, so require digest, and then MD5.new. Yeah, require digest. Okay, so let's grab that. Thinking an MD5 hash is going to be sort of the easiest way to recognize if we have two versions of the seating chart that look the same. So we have that, and then I guess I want a 2s. So maybe if we create a 2s function, we can actually simplify our display. So say seating chart dot each to dot map perhaps, and then we'll say row dot join, and then we'll say join here, but with new lines, and that'll be our 2s. And then this can just puts out the 2s. that work if I run that? Will it print it out? Nope, unexpected end. 108. Grid display puts grid.occupied. Huh. Where did we go wrong here? Def display puts 2S. Mismatched end with def 41. Oh, my bad. So that doesn't print it as nicely. Did I miss something? Display puts seating chart to S. Oh, self to S. Okay, there. That looks nicer. So then I can just ditch that and ditch all of that. So now each time we tick the grid, we're going to get a previous state hash. And I think also when we occupy all seats, we're going to want to say previous state hash like that. And so then our chaos stabilized, we can say yeah, the reason I'm thinking is because I realize this actually isn't representing the previous state. This is representing the current state. So what we actually want this to be is a digest of the seating chart. Then we update the seating chart, and so what this now represents is different than what we've hashed here. So we have to update that here as well. And I need to call 2S on both of these. That's my bad. Okay. So now we actually have something representing the previous state, which means we can say, yeah, basically just do a check. Does the digest of the current seating chart 2S, does that equal the previous state hash? And if it does, then the chaos is stabilized. And so we can now that we've got all these pieces in place, I think we can kind of skip all that. We can say grid dot occupy all seats, and then we can say while grid dot chaos stabilized, while it's not stabilized, and we will say grid dot display. We'll say grid dot tick, grid dot display, and then once we've stabilized, then we will say puts grid dot count occupied, and hopefully this prints a succession of grids and then prints out 37. And it does. Okay, so I feel good about that solution then, and now I would like to grab this rather large puzzle input, which I'm going to Command A, make sure I get it all, and we started with sample.txt, so what if we go input.txt, paste it all in like that. Cool. And we jump back to part 1, change that to input and give it a run. It runs for a while. You could actually kind of see it moving as it was printing to the screen like that. So we end with 2, 3, 4, 6. Will that answer do it? All right, we got it. 1 gold star for the day. That was a lot of fun doing a Conway's Game of Life type thing. I'm interested to see what is in store for us in part 2, but for now, thanks for watching.